Long before the Himalayas existed, the Indian subcontinent was not attached to Asia. It was a large island continent, drifting slowly northward across the planet. Between India and Eurasia, the Europe-Asia landmass, lay a vast body of water known as the Tethys Ocean. The Tethys Ocean was a major ancient oceanic basin, far larger than today's Mediterranean, separating the Indian subcontinent from Eurasia. Beneath it lay a dense basaltic ocean floor covered by thick layers of marine sediments, mud, sand, limestone, and the remains of ancient sea life. As the Indian plate continued its steady northward movement, it began to close the Tethys Ocean, slowly, progressively, over tens of millions of years. The first major change occurred beneath the ocean itself. The oceanic crust of the Tethys was thin and heavy. When it had encountered the much lighter continental crust of Eurasia, it behaved exactly as physics predicts. The denser material sank. This process, called subduction, caused the Tethys ocean floor to slide beneath the Eurasian plate, piece by piece, descending into Earth's mantle. But not everything followed the ocean floor downward. The softer sediments resting on top of the Tethys seabed were too light to sink. As the dense crust moved downward, these softer layers were scraped off, much like wet sand piling up in front of your hand when you slowly push it across a beach. Over time, these sediments were compressed, folded, and stacked along the boundary between the two plates. Marine fossils found in the Himalayas are remnants of this ancient Tethys Ocean, which once covered this region before the mountains existed. Over millions of years, shells and marine organisms accumulated on the ocean floor as sedimentary rocks, such as limestone. When the Indian plate collided with Eurasia, these lighter sediments were scraped off and uplifted rather than subducted, carrying marine remains thousands of meters above sea level. As these rocks erode today, they release mineral-rich sediments into rivers like the Indus, Ganga, and Brahmaputra, contributing to soil fertility downstream. The carbon stored in marine limestone also plays a role in Earth's long-term carbon cycle. As the space between India and Eurasia narrowed, the water was gradually pushed outward, flowing into surrounding ocean basins. Most of it merged with the Indian Ocean, while portions flowed westward, contributing to what would later become the Mediterranean Sea. Eventually, after millions of years, the last remaining Tethys oceanic crust was completely consumed. The Indian continent finally came into direct contact with the Eurasian continent. Continental crust, unlike oceanic crust, cannot sink easily. Instead of subducting, the two landmasses began to thicken and deform under pressure. A useful way to visualize this is to imagine two thick carpets slowly pushed toward each other on a floor. Neither carpet disappears. Instead, the material buckles, folds, and rises upward where the pressure builds. In the same way, as India continued to press northward, Earth's crust shortened and thickened. This uplift created the Himalayan mountain range and raised the Tibetan plateau, and the process did not stop. The Indian plate is still moving north today, and as a result, the Himalayas are still growing. This growth is slow but measurable, driven by continued compression and thickening of Earth's crust. At the same time, erosion is constantly working in the opposite direction. Rain, rivers, glaciers, and gravity wear the mountains down, breaking rock into sediment and carrying it downstream. The Himalayas remain high because uplift and erosion act together, maintaining a long-term balance between growth and removal. But what if this growth were to stop? That balance would be lost. Erosion would begin to dominate, slowly lowering the mountains over geological time. River gradients would weaken, sediment supply would decline, and the fertility of downstream plains would gradually diminish. The Himalayan barrier that shapes South Asia's climate would erode, altering monsoon patterns, making the region drier, more seasonal, and less reliable for agriculture. The Indian plate's ongoing northward motion keeps the Himalayas high, rivers active, and South Asia climatically viable, while simultaneously generating earthquakes and instability. The very force that endangers the region is also the one that sustains it. If you like the content, please like and subscribe.